particle in 1D box from minus L by 2 to plus L by 2. It is in its ground state. Okay, speak up. The walls of the box, it is suddenly expanded to minus L to plus L. Suddenly expanded. Suddenly expanded. Okay, that word is important. I will show you the question. Okay, how they are designing the question. Okay, suddenly expanded minus L to plus L, so that your state is momentarily unchanged. What do you mean by that one? This is minus L by 2, this is plus L by 2. The state is momentarily unchanged. We say like this. I mean, I did sudden expansion here. So now this is the state. Okay, speak up. Now you do the energy measurement immediately. You do the energy measurement immediately after the expansion of the wall. So then look at here. Once new wall happens, okay, what are your E and new? I mean, now you are doing the measurement on the particle which is confined between minus L to plus L. Okay, outcome should be, I mean, new box energy eigenvalues. Okay, state should collapse to new box eigenfunctions. Is that okay? Speak up. That's why E and new, that's equal to n square pi square h bar square by, so 2m into 2l the whole square. Am I right? I mean, if you do any measurement here, okay, now system is particle in a box which is confined between minus L to plus L. Total length of the box is 2L. Okay, you will get eigenvalues like this actually. Okay, so what are this psi and nu? Psi and nu, speak up. Root of 2 by 2L cosine of n pi x by a when n is 1, 3, 5 and so on. Okay, 2L here. Okay, 2L here. Okay, root of 2 by 2L sine of n pi x by 2L. Okay, when n is equal to 2, 4, 6 and so on. Okay, I mean symmetric states actually. Okay, but I mean look at here, they could have asked the question like this. Okay, this is the box and this is your initial state. You did the measurement, what is the outcome and all. They didn't design question like this. They gave particle in a box from minus L by 2 to plus L by 2. It is in its ground state. Now walls are suddenly expanded. Energy is measured. What is the outcome? They defined this state indirectly. Speak up. Now this is the state before the measurement. Are you getting my point? Speak up. Let me show you the question here. Okay. Read the question. They could have defined the state in the new box because you are doing the measurement after expansion. Am I right? But they didn't do like this. They defined the new box state from this one. Now this is your state before measurement. This is your state before measurement. Is that okay? This is your psi state before measurement. Are you getting a point? Which is non-zero only between minus L by 2 to plus L by 2. It is this function. It is zero outside. That can happen. Am I right? Our initial state that can be zero in some region of the box. Am I right? I mean that problem equally likely in the left half of the well. It can be there. And this state can be expanded in terms of this Fourier expansion. Any function you can expand. I mean, your triangular wave, am I right? That triangular wave, it was zero half of the time period actually. You expanded as a Fourier series like that. It may be zero here, but it can be expanded in terms of these eigenstates. Okay, I mean, those eigenstates are, pick up. I mean, suppose if I draw this is a ground state, okay, first excited state like that. Okay, I mean, using them you can generate this function. That's what I'm saying. Okay, using the eigenstates of the new box, okay, you can generate the function, this function. Is that okay? Speak up. Now the idea here is, okay, speak up. State before the measurement. Okay, speak up. Whatever you have, okay, state before the measurement. That was this function cos pi x by L, am I right? Minus L by 2 to plus L by 2. That can be expanded as Cn into psi n nu. Is that okay? That can be expanded as Cn into psi n nu. Okay, speak up. Now, what is the probability of getting? Speak up. Probability of getting some En nu. Don't expect any old box eigenvalue. Now the system is particle trapped between minus L to plus L. You should get these eigenvalues. Isn't it? That's equal to, speak up, mod Cn square. Now observe carefully. Observe carefully. Okay, I mean, suppose if you wish to find probability of getting, okay, E1 new. Okay, probability of getting E1 new. That old box, it is just defined, it is just given to generate this state. That's it. Suppose I want to generate this state, what would you do? I want to generate this state, which is cosine between minus L by 2 plus L by 2, 0 here. What would you do? This is how you generate, isn't it? So that's why, look into this one carefully. This E1 new, okay, speak up. This E1 new, probability of getting E1 new, that's equal to mod C1 square. Now, I will not do the problem like this. What I will do? Integral, okay, psi 1 new, this is state after the measurement. Star, state before the measurement, psi bm, okay, that I have mentioned over there, okay, into dx. What is the integral range? Minus L to plus L. This is full range of interest, okay, the mod square. Can I write like this? So now look at here, this psi 1 new, that is defined between minus L to plus L. But psi bm, that is defined between minus L by 2 to plus L by 2. That's why this is 0 in this region. That's why product is 0. So integral will be converted into, can I write? Speak up. That integral is equal to, speak up, minus L by 2 to plus L by. Remember, both of these should be normalized individually. Okay, speak up. Minus L by 2 to plus L by 2. What is psi 1 new? Are you getting my point? Why it is converted into minus L by 2 to plus L by 2? Because psi bm is 0 outside this region, isn't it? So that's why this is equal to, what is this one? Root of 2 by 2L, psi 1 new. Psi 1 new, root of 2 by 2L cos, speak up, pi x by 2L when n equal to 1, isn't it? Multiplied with, what is psi bm? Root of 2 by L, root of 2 by L, speak up, cos of pi x by L dx. Can I write like this? Minus L to plus L, but this function is 0 outside. That's what I'm saying. This one, psi b.
We are just measuring after that, what we just after that.
I mean, even though time evolves, okay, this probability of energy measurement, that won't change. Don't worry. Even though time evolves, on this state, if you do measurement at t equal to 0 or later time, it doesn't matter. You take t equal to 0. You take the simplest case. Is that okay? Energy measurement. Okay, speak up. Mod square. Are you understanding this one? Now let me ask one more question. What is the probability of getting E2 new? What it will be? Psi 2 new. Am I right? What is psi 2 new? Sine. What is that integral? Minus L to plus L. I'm writing directly. Okay, speaker. Minus L to plus L. Psi 2 new is the state after the measurement. Okay, speak up. State before measurement. Remember, state before measurement is 0 in some region. That's why this full limit will not survive. Okay, speak up. Product will be 0 in some region. What is this one? Can you quickly? Minus L by 2 to plus L by 2. Okay, root of 2 by 2L. Okay, sine of 2 pi x by 2L. Am I right? N equal to 2. Okay, speak up. Multiplied with root of 2 by L cos of pi x by L. What is this integral? Speak up. Why? 0. Why? Odd function. The idea here is very simple. Look at here. This is even function. You are expanding it in terms of cosine and sine. Fourier series. Ordinary Fourier series. Cosine and sine both come. I mean, even function, its expansion should contain only even function, not odd function. Check that out. Even and odd function Fourier series we did. Even function expansion contain only cosine. Odd function expansion, I mean, if our limit of interest, if it is symmetric, odd function expansion contain only sine. Check that out. That is the idea. In its expansion, I mean, this expansion means in its what you call superposition. I mean, in that superposition, only cosine states will come, not sine state. Why? This is even function. Even function expansion should contain even functions only, not odd function or mixture of even and odd function. That will make it neither even nor odd, isn't it? It's very simple. This is even function. I mean, you think of Fourier expansion here. So that's why these state will not contribute at all. And probability of finding any of that n equal to 2, 4, 6, those energies, that's 0. You got my point? I mean, this kind of ideas can be explored. This is 0. That is non-zero. Usually they ask what is the probability of getting ground state of the new box. What is the probability of finding it again in the ground state? That's the usual question that they have asked. You got the idea? Initial state is defined in slightly different manner. I mean, they said it is my old box. It was in the ground state. I am suddenly expanding. Now you generated one state for the new system. I mean, this is your system. For that, you generated one state which is cosine minus L by 2 to plus L by 2, which is 0 outside. You generated one state. And on that, you are doing the measurement. Okay. Again, I mean, state before measurement, state after measurement, inner product mod square. That will give you the answer. But be careful about the range. Okay, this is 0 outside some range. Okay, so that product will be 0. So in this range, the L by 2 to L minus L to minus L by 2 in that range. Okay, that's why this will be converted into this one. Again, if you do the old integral, I mean, that would be wrong. Okay, I mean, minus L to plus L integral, that would be wrong. Okay, speak up. This function, okay, its range is different. Okay, either okay, that function. What is this one? Particle is confined in a infinite square well from minus L by 2 to plus L by 2. It is in its ground state. He mentioned ground state wave function also. Check this up. The walls of the box are suddenly moved between minus L to plus L. That is the first example that I took. What is the probability that it is found in ground state after this sudden expansion? Non-zero. Probability is non-zero, we saw. Because ground state is again cosine function. Ground state of the new box, that's again cosine function. Cosine into cosine. Initial function, state before measurement, state after the measurement. That inner product survives. That integral survives. Okay. But first excited state probability is 0. Why? First excited state is sine function. Your state before measurement, that is cosine function. Anyway, your limit will be symmetric only. Okay. Speak up. Can you do that one? Consider a quantum particle in one-dimensional box of length L. Coordinates of leftmost wall is x equal to 0 and rightmost wall is x equal to L. 0 here, L here, okay, as a function of x here, okay. Then particle is in the ground state at t equal to 0. Now, I could have written this one as psi 1, but I don't write like this because this is the state on which you are doing the measurement later. Okay, this is the state before measurement actually. Okay. What is this one? It's in the ground state. What is the ground state? Root of 2 by L. Root of 2 by L, 0 to L. Sine. Old box. Speak up. Sine pi x by L. Who said cos? When x is between 0 to L here, 0 otherwise. Isn't it? It's in the ground state of the box. Okay, that's what the particle is in the ground state at t equal to 0. Okay, at t equal to 0, we suddenly expand the box from 0 to 3L. 3L here, L, 2L and 3L. Okay. By moving the right side of the wall. Okay. That's why left side is at 0 only. This is at 3L. So, I mean, that sudden expansion will not change the wave function. Wave function is still the same. Now, on this state, particle is in this state in the new system. This is the system. Okay. Now you are doing the measurement. What is the probability of particle is in the ground state? Look at here. They didn't ask what is the probability of finding the particle in that energy. They said what is the probability of finding the particle in ground state of the new system immediately after the same. Look at here. Even after some time also, the probability, energy probability, that remains the same. Okay. Speak up. Energy probability, if I specifically say. Okay. Speak up. So then, what is this one? I mean, you have to do it directly now. Okay, what is this one? Probability of getting ground state of the new system. Am I right? That is probability of getting psi1 new. Pick up. What is psi1 new? Psi1 new, that's equal to root of 2 by 3L sine phi x by 3L. What is the range? 0 to 3L. So that is 0 to 3L. Okay, psi1 new star. This is the state after the measurement. Am I right? If you get E1, this is the state after the measurement multiplied with state before the measurement. Why I have written this one as capital psi? Because for the new system, this is not stationary state. Why I'm writing, I mean, where I have written capital psi when it is superposition state? Because, I mean, this may be eigenstate of old box, but not for new box. For new box, it is like this, it is 0 here, it's a superposition state for a new box. Is that okay? Very simple. It contains infinitely many terms actually. So into, okay, dx the mod square. But be careful, your integral limit should be full range of our system. Okay, speak up. But this psi bm is 0 between L to 3L. Am I right? L 2L 3L. Am I right? Between this region. Okay, pick up. That's why that integral will be converted into, give a minute. That integral will be 0 to 0 to L. Am I right? Because this is non-zero, only 0 to L. Speak up. This is now psi bm. Okay. State after the measurement, that state is this one actually. Am I right? Ground state of the new box. This is the state after the measurement. Am I right? Speak up. This is psi1 new. This is state after measurement. Is that okay? Got my point? Speak up. When you multiply these two functions, it will survive only 0 to L. Am I right? It is 0 outside region. 0 to L. What is this one? Psi1 new. What is that one? Root of 2 by 3L. Okay. Sine phi x by 3L multiplied with root of 2 by L. That's the ground state of old box. Okay. Root of 2 by L into sine phi x by L. Okay. Into dx the mod square. And you need to neatly do this integral. Sin A, sin B formula. Okay. This neatness does matter. If you now up to this one, if you couldn't do the integral, exam will tell you that you are not eligible. Neatly do this integral. 1 by 3, I think sin A, sin B. How do you write? Cos A plus B, cos A minus B. Am I right? 1 by 3 plus 1, 1 by 3 minus 1, like that will come. So neatly do that one and find the answer. Okay, speak up. Look at here how the answers are. Okay, like this.
That side view can be said like it is first stationary state. Side view.
Psi bm is not stationary state of a new box. It was stationary state of old box. Old box is not our system now while you are measuring.
How that changes
How?
How that change occurs?
No, that he didn't mention. How practically we move the wall, that we don't know. I'm suddenly moving the wall. Okay, what they did is this psi BM they generated like this. This you generated one state using this process. Hmm? Now this is the system. This is psi BM. That's it. I mean, now you can rub out this one. This is just one hint to generate this state, isn't it? This is the system. This is the initial state. Just like particle is equally likely half of the well, other half wave function was zero. We generated that state somehow. Like that, it is the state. It is some sign function 0 to L, and it is 0 in this region. And is this state any eigenstate? No, am I right? Or eigenstates are like this, isn't it? Of the new box. So that is not eigenstate. Okay, that is linear combination state in the new system. That linear combination state contains infinitely many terms. Look at here. With one or two terms, you can't generate this function. With one or two terms, it is infinitely many terms actually. Speaker. Just like I think in Fourier series, I didn't ask any question regarding half wave rectifier, Fourier expand half wave rectifier like that. Like that. Okay, speaker. Any question here? And this integral should be done very neatly. Okay.